Okay, so we have 4 different functions: f of x, g of x, h of x, and r of x. And I want to give you real world situations, and I want you to see which function best models that real world situation. Now notice down here it says, notice that all of these c values are 0, right? And the only reason why I did that was so you could kind of think about an xy plane. If your c value is 0 and you wanted to find your y-intercept, that would mean that it would cross the y-axis at 0. Okay. Remember, to find the y-intercept, you set x equal to 0 and solve. So if these are 0, your c value would be your answer for the y-intercept. So by me putting the c value right there, it'll either it'll make some type of parabola that crosses through the origin. So your parabola might be like this, really high, or might be just kind of like that, or it might be really steep going down, or just kind of, it all depends on your vertical stretch or compression, right? Anyway, I know that might sound a little confusing right now, but let's just take a look at the first situation. Which one of those would be the path of a football pass for a touchdown? Okay. So everybody jot down this one right below your 4 functions. Write down the path of a football pass for a touchdown. Okay. And I want you to talk to a partner and think about how the ball travels when a quarterback throws a touchdown pass, right? What kind of parabola will model that path? Will it be a parabola that opens up, a parabola that opens down, a parabola that's really wide, a parabola that's really narrow? Talk to a partner, and of course you could decide all that just by evaluating and talking about your a value of the standard form quadratic function.
No.
No? You don't want to? Okay.
No, because I don't like that.
Everybody? Nobody? Keep going. Go for it.
I honestly have no idea.
You have no idea? That's okay. All right, guys. Let's first start evaluating the f of x function. Is this going to be a parabola that opens up or opens down? The a value is negative, which means it's opening down. Now, we already know that if the a value is close to 0, it's wide. If it's further away from 0, it's narrow, right? If it's closer to 0, it's a compression. If it's further away from 0, it's a stretch. So we know we should have an idea that this parabola, f of x, is opening down and it's pretty narrow. Do you think that's how a quarterback would throw a pass?
No.
Heck no, right? If we look at the next one, g of x. Well, this next one, g of x, put a blue dot right there. That one's opening up or down? It's opening up, all right? Is it wide or is it narrow based on that a value? It's close to 0, so it's pretty wide. So it's opening up and close to 0, so it's pretty wide. So does a quarterback throw a ball and it goes down like that and then back up? No, right? Okay. So what do you guys say? Which one is the best one for the path of a parabola where the last one. The last one, absolutely. Good job, Victor. So the last one has the a value of -1/24, okay, which means that it's opening down. So let me just do a rough sketch in green here. So it's opening down, it goes up, and it's pretty wide, and then it comes back down. That's the best description or the best model for a pass in football, okay? So everybody write down, right underneath number 1, write down r of x, and write down r of x is -1/24 x squared plus 6/8 x. That's your answer for the path of a football pass for a touchdown. Or you could draw an arrow if you want. If you already have it listed up there, you could just draw an arrow to show that that's the one is your answer. So let's move on to number 2. Go ahead and talk to a partner. I want you to decide which function would be best to model the path of a swimmer underwater as she dives into the pool at the start of a race. Okay? Okay, maybe I shouldn't have drawn this stuff because you guys could see that pretty well, right? So what would be the answer there? G of x, right? G of x would be the best one, right? Because if she jumps into the pool and she's racing, she obviously doesn't want to go too deep. She just wants to be kind of go into the pool and then pop back up and then keep swimming on the surface, right? Okay, so number 2 is g of x. Everybody write that down. The path of a swimmer underwater as she dives into a pool at the start of a race, that would be g of x. Copy down g of x. Okay, next situation, I want you guys to copy this one down. Let's get 2 out of the way. 3 is right here. The path of a pop fly in baseball. Jot that down, please. So if you think about a pop fly, somebody hits a ball, it goes pretty high up in the air, and then it comes back down. Somebody usually catches that ball, and that is a parabola that opens down. So obviously it's either r of x or f of x. Now this one would be really wide. That's not that situation. This one's very narrow, so that would be the correct one for the path of a pop fly in baseball. So everybody jot down f of x is that number 3, the path of a pop fly in baseball. So let's try number 4. Says the path you will take when bungee jumping off a bridge. So write that down. So if you're on a bridge, you're going to jump off. Bungee jumping, you're going to go down and then bounce back up, right? So, which one would that be? H of x, right? H of x, because it's positive, that means that it opens up. That's what you want. It is vertically stretched, which is pretty narrow. Okay. So do we understand how we could tell which parabola best models which situation with the a value? Yes? Okay. How about this? Let's be more specific and let's go to the swimmer. Let's go to that swimmer one and tell me, how deep does she actually go into the water when she actually dives in? What's the furthest, what's her lowest height in the water? How do we figure out the lowest position of her in the water as she dives in? How do we figure that out? The what? The C value? The C value tells you where it would cross the y-axis. That's where she begins, where she jumps into the pool, right? Well, my question is this, like, let me actually draw it for you. Here's an XY plane. She starts here, she jumps into the water, and she goes deep, and then all of a sudden she pops back up and she continues swimming on the surface, right? My question is, how deep underwater does she actually go? Obviously, it's not going to be too deep. She's not doing a high dive and going way down here in the water. She's racing, so she's only going to go down a bit and then pop back up and then continue swimming. Make sense? So how deep does she actually get at the beginning of this race when she first jumps into the water? How would you figure that out? Anybody? If I'm looking for this location, think about that. On an XY plane, what is that location? What do we call this piece, which is the lowest piece of a parabola? The vertex. The vertex, right? So go ahead and find that vertex so we can see how deep she actually went in the water. This is number 2 here. Go for it. All right, how about this? How do I find the vertex, guys, of that g of x function? How do I find the vertex? X equals negative b over 2a. Now, whenever you use that formula, you want to use parentheses instead of the b and the a. That way you could easily plug in your b value of negative 1 and your a value of 1/14. So b is negative 1, the a value is 1 over 14. Okay, so when we're working out this x value of the vertex, you have to change the minus minus up on top to a plus plus. You end up with a 1 up on top, and on the bottom you put the 2 over 1 and multiply 2 times 1, that'll be 2, and 1 times 14, that'll be 14. So you have 2 over 14. And let me rewrite this as 1 up on top divided by 1 over 7 on the bottom. Now that might look confusing. That's because you're writing this division problem vertically as opposed to horizontally. So it might make more might make more sense to say 1 divided by 1/7 horizontally. Check it out. 1 divided by 1/7 horizontally. Because when you divide by a fraction, you change the division to multiplication. So you'd really have 1 times 7 over 1. You have to flip that second fraction. I hope we all know this from Algebra 1.
Yeah.
So what's 1 times 7 over 1? That's just simply 7, correct?
Yes.
Okay, so that is not how deep she is. This is barely the x value of our vertex. We still need the y value. So to figure that out, we're going to have to, plug in that x value of 7. So let me rewrite this over here on the side. We have 1 over 14 x squared minus 1 over x. There is no c value. And we said we are plugging in 7. So we're going to have 1 over 14 times 49 minus 1 times 7. That's just 7. So we really have 49 over 1 times 1 over 14. That's 49 over 14 minus 7. So calculator time, if you go 49 divided by 14, that's a 3.5. 3.5 minus 7, bless you, that's going to be negative 3.5. Okay? So that makes total sense. The vertex is 7 and negative 3.5. So if we think about the swimmer, she's about to jump into the pool, right? And the vertex is at 7, negative 3.5. So she dives in, and as she travels 7 feet this way, she reaches a max depth of 3.5 feet, 3.5 feet deep. And then she pops back up and continues swimming. Okay? Anyway, that's just to warm up your brain for parabolas, which is what we're doing today.